Problem 35 is an assignment problem. We have 4 people that have pooled together to buy season tickets to a set of 8 games. They have each ranked their preferences, and 1 being the highest preference, 8 being the lowest preference for a game. Each of them should get 2 tickets to the 2 of the 8 games. And what we would like to do is award these tickets in such a way that the net rankings are maximized so everybody is as happy as possible. If you take a look at the Cowboys game, both Al and Carol have ranked that game number 1. Only one of them is going to be satisfied with that ticket to that game. Barbara has ranked it number 2. Dave is ranked at 4th. Dave will not likely get that particular game, but it is conceivable that Barbara might get the ticket to the Cowboy game if it maximizes the overall satisfaction or ranking. Now, we have got 8 games, 4 different people that can get tickets, so we have a total of 32 different decision variables for this problem. And we're going to assign these or identify these decision variables based on the game and the person. So let Xij represent the decision to give ticket I to person J. Decision variable X1b would be the decision to give that Cowboy ticket to Barbara. 2 is the rank of that game by person, or the rank of the Cowboy game by Barbara. So Rij is the rank. Those are the numbers that you are looking at right here. And again, those are not decision variables, those are ranks. We know how Barbara ranked that Cowboy game. We know how she ranked the Redskins game. That is not a decision variable. Now, with 32 decision variables and 32 ranks, our objective function could get a little bit lengthy here. So we're going to write this in 2 ways. Shorthand, we are going to maximize Z being the overall satisfaction or ranking, as the sum over I and J, Rij, Xij, the rank times the decision to use that ranking. And writing that out longhand to get that started, let's go up a little bit here. 1 X1A plus 2 X1B, giving that ticket to Barbara, plus 1 X1C plus 4 X1D. That takes care of the Cowboy game. The Redskin game would start out 3 X2A and so forth, all the way down to 2 X8D. That's our objective function. Now, 2 different types of constraints for this assignment problem. We need to ensure that the Cowboys game is assigned, and we need to ensure that each of the people gets 2 games. So we'll have a total of 8 supply constraints, and we'll have a total of 4 demand constraints. Supply constraints. First supply constraint, X1A plus X1B plus X1C, X1D, that's that Cowboy game, it has to be assigned. The Redskin game, X2A plus X2B, X2C plus X2D has to equal 1 as well. 8 of those constraints, 1 per game. The demand constraints, we've got 4 people, starting with Al, X1A plus X2A plus X3A on down through X8A. Has to equal, Al's got to get 2 tickets. Barbara, x1b plus x2b plus x3b, and so forth through x8b has to equal 2. So we'll have 4 of those 8 supply constraints. And xij, we can do this 2 ways. We can specify that these are binary, but because this is an assignment problem, xij, the structure of the problem, will give us binary decision variable, or it should give us a binary decision variable, if we simply say that those have to be greater than or equal to 0. Going to Excel. Again, these are the rankings. They are not the decision variables. Here are the decision variables. What we are doing for our problem is maximizing the ranking. So we'll come up with a net rank, some product of the rankings and the decision variables. And that is going to be our objective function. Our supply constraints. We're simply summing row by row. And we're summing column by column. Left-hand side for the supply constraints is 1. Left-hand side for the demand constraints is 2. To solve this problem, we're going to bring up Solver. Our target cell is going to be the net rank, and we want to make that rank as low as possible so that people get their best ranked games. Changing cells, our decision variables, our constraints, supply constraints, so left-hand side is equal to the right-hand side. The demand constraints, left-hand side, is equal to the right-hand side. We're going to forgo the binary condition or constraint at this time and simply try the linear and non-negative constraint. Again, making a binary decision variable can make the problem more difficult for the computer to solve. The structure of the assignment problem should give us a binary solution even without requiring a binary. And our solution, our net rank is 24. Al is going to the Eagles and Bengals, Barbara to the Saints and Jets, Carol gets the Cowboys and Packers, Dave gets the Redskins and Cardinals.